Hi everyone, Krishna this side. So in this video, I'll be covering the same problem that I already covered in the morning, but this time I'll be using the depth first search. In the morning, we have seen BFS approach, and we have seen that it was quite working very well in terms of runtime and as well as memory. But yes, we'll try to see if with the help of DFS, whether the solution is going to improve or just to get the idea like how we can write the code into DFS as well. For the sake of that, I decided to make this video. And another thing is, yes, whatever the time complexity that I have discussed in the morning, it was not appropriate because I was hurry as in market was getting open, and I have to focus right over there. So whatever the thought process that I was getting right over there at that time, I just collected and tried generating the complexity, but it was not correct. So we will in detail try to understand the time complexity as well. And if you are new to this channel, please make sure to subscribe this one because making this video basically takes some time. So yes, subscription only going to help me motivated and keep uploading the better videos with the coming time. Yes, please make sure to subscribe to this channel as well. And let us see. Again, I'm not going to discuss the same problem. You can pause the screen and watch the go through the problem statement. The only idea is like we have to figure out the longest subsequence, okay, from this particular string, which basically got repeated two times. Okay, whatever the longest subsequence length that we got, that string is something what we have to figure out. So if we see in this particular string, this let basically appeared at the first here, and then it is like again it is been appeared, right? So it is having appeared two times. So yes, LET is one possible answer. Again, after LET, there are few of the options as well. Like ETE, it got appeared two times. Okay, it is also having length three. So out of these both of them, which is the lexicographically largest one, that is something what we have to figure out and we have to write into the output. Okay, so LET is basically lexicographically largest one. Okay, so yes, that is the answer that we get it. Okay, so yes, let me just connect the screen and I'll explain you right over there. I hope the screen is up for all of us. Now this is the string that is been given and k value is basically equals to 2. The first thing that I already explained is like let us try to get the frequency which is having values greater than or equals to this 2, because if the character is not appearing actually k times, obviously with that particular character we cannot form any subsequence k times, right? So yes, the first thing is like we will collect all the characters which appeared actually k times or more than this. So A basically appeared two times, B basically appeared two, C appeared two times, E and D are actually appearing one time. So we will not consider them at all. Okay. So this is like we will store it in array list or some set, something like that. The moment we collect all these values, what we will do basically we'll try to generate all the different possibilities. Okay. Initially, let us suppose the string is empty. Okay, and now we can have either A, B or C. Out of these three characters we can get the answer. Okay, at first level any one of them, because these characters are basically appearing two times, so yes, a single character is going to be a subsequence, and that is going to be answer as well. So out of this, whichever the maximum one, that can be the answer. Okay, so initially what we will do is we will start with A. Okay, we have all the different possibilities, okay, generating the strings. Then we have B, then we have C. Okay, with A we will try to generate all the different possibilities. Okay, the first possibility is going to be it is like A. Then we will see that whether this A, whatever the character that we generated, okay, whether this is actually appeared two times or not. So here is A, here is A, but this A is the first thing that we got. Again, A should be there, then only we will get to that it got appeared two times, but yes, it is not available, so we are done with this one. Okay, we will not start exploring further. The next one is like it is going to be AB. So we will check that AB if it has been appeared two times. So here is AB, here is again AB. So yes, AB is acceptable. So we are again start exploring to this particular one. Okay, in the DFS we will keep on going in the downside until and unless we break somewhere. Okay, so yes, that is how the BFS approach works. DFS approach works. In the BFS, we basically goes on level wise. So this is like first level that is there, then it is like second level. So in that fashion, we basically go in the breadth first search. But in the DFS, we will keep on going with any particular values that we are currently exploring. Okay. So now AB is done. With this AB, we again have three options like AB, A or ABC, sorry, ABB, and there is like ABC. Okay, these are the three possibilities that we have. We will check that whether this ABA has been appeared two times or not. So here AB and A, the first string has been done. Again, if we start looking in this particular area, there is no ABC or ABA. Okay, so this is also not a valid subsequence. Okay, which is actually appearing two times. Then there is like ABB. So we check that AB is actually here, B is actually here. The first subsequence got it in this particular area. We will try to see in this next area. There is no ABB. Okay, this is also not valid one. The next one is like ABC. So ABC is actually appeared right over here. The next ABC is like here and here. If we consider this, it is also possible subsequence, right? So the subsequence is like when we delete any characters in between the characters also, whatever the string that we are generating, it is going to be a subsequence. So yes, ABC we found it in this first ABC, we found this in the area, and another ABC we found this in this area. Yes, it is a valid one. So this could be an answer. Okay, we got to know. Apart from this, we do not have any other options because we are actually generating strings with the help of these ABCs only. Okay, so yes, we actually ended our loop basically ends right over here at this particular place only. Now ABC with this AB sorry, with this AB we generated all different possibilities, and this was a valid one. That is something what we got. Now next one is like A, B and C. Okay, we are basically just simply trying with A. We actually checked. Now A, B we will check, A, C we will check. Okay, this is like how we will keep on checking the data. So again, for this AC we have three different operations like ACA, ACB and ACC. Okay, so we will simply check that whether this particular is actually a part of subsequence or not, whether this is part of subsequence or not, whether this is part of subsequence or not. Okay, this way we'll keep on checking. Okay, but before going right over here this ABC was a valid one, right? So ABC, since if it is a valid one, we will try to explore again further possibilities. Okay, so it is like ABC A first possibility. So we will check that whether this ABC A has been appeared in this one. Here it is the first one, second is not available in next range, so we are not having any possibility with this one. ABC, then there is a B. We will check that ABC B is actually available in this range, but there is no ABC B CA. Okay, CB. Yes, all the different possibilities if we try for three possibilities that we get, with this none of them are actually answers. So far it is the best answer that we got. Okay, so answer is something what we will keep on maintaining at any point in time. If length, whatever the new exploration that we are doing, if its length is actually greater than current previous answer, so we will simply update the answer. Okay, that is what we have done in the morning as well. So we will explore AC we have seen it is also whatever the values that we are getting with the AC, none of them are the answers. The next one is like B. For B we will keep on exploring all the different possibilities. So they are like B, it is like BA first possibility, then BB, then third possibility is BC. Okay. So here it is like BA, we will check whether BA is the possible answer. B and A are right over here. Okay, B and A are right over here, here and here, but in this next substring we will not having any BA. Okay, so B is not possible answer. BB we check, BB is also not possible, and here for BC, here it is one, and here in this range there is actually another one, so this is possible. So again we will try, keep on trying further possibilities for this one. So B, C, A is the first possibility, so BC A is actually appearing right over here. Okay, BCA is actually appear right over here, but in the future we are not having any BCA. BC is actually available, but A is not available in that one. Okay, so yes, this is also not an option. Then it is like BCB. So BCB, for BCB, if we look here, BCB is there, but again future it is not there. So yes, it is also not option. And then BCC is also last one. So for BCC also it is also not a part of subsequence. Okay, so we are done with this one. Okay, so far maximum answer that we got was A, B, C. Okay, A, B, C was the maximum answer. So in the answer, A, B, C is the highest answer. Okay, so each time whatever the character we started exploring, that is going to be the maximum. And at any point in time, if in the next range we got the maximum answer, we will simply update the answer. Or if the lengths are equal, we have to consider the lexicographically largest one. Whatever the current string that we have in with that string, whatever the previous answer we keep trying to check, if that is the best one, we will simply update it. So far answer is ABC. So with the B, we explored all. With the C also, we will try to explore all the possibilities. Whatever the possibilities that we are getting, we will simply check that if those are subsequence or not, and if they are, then the answer is going to get updated. Okay, this is like quite simple, and same with the BFS, we just use Q here in this one. We'll keep on going downside. In the BFS we basically goes level wise. Here in this one we will go I mean, once we started exploring for any particular one, we'll keep on going until we have no further possibilities. Okay, that's how DFS basically works. Let's quickly modify the morning's code, and after this, we will discuss about the complexity. Okay, it is again important one because we just decided random stuffs in the morning, and that way I just explained it. But I'll explain you in a proper way. The first thing that we do is just get the frequencies. Okay, once we get the frequency, we create array list, and the array list we simply check that if any frequency is actually greater than or equals to k, then only we will add that character into the list. This code is not necessary to modify, and from here we actually used q, okay, for bfs, so we simply remove this one. Okay, that is the first thing that we have done. Next thing is like whatever the answer that we have created, this let us keep it outside, so that at any point in time in any recursion call, if new answer is actually greater, so we will simply update it, because in the recursion either we have to use immutable objects. Okay, let's try to use actually whatever the string builder and all those things are there, right? But in the backtrack we have to remove whatever the new value that we added into that one. Okay, that way we have to maintain it, so it's better to use string and keep it outside. And next thing is like let's just simply remove it. But from this while loop, I basically require these conditions only, and this whatever the conditions that we have applied, these are the base conditions for anyone. Okay, so yes, let me just copy this and let me just remove all these values. Okay, and this was the morning's code, and answer is something what we will return it. Here what I'll do is I'll just simply call the DFS. In the DFS, first thing is like from the list whatever the characters that we are getting, with the characters only we are just trying to form a strings, right? So list is something what I'll pass right over here. The next thing is like basically the string, the k, and current string is basically empty, so whatever the new current string that we are generating, that should be with us. Okay, here what we will do is we simply create this DFS function, public void DFS. Okay, in this DFS, first is like array list of character, and this list next is like a string, so string yes, and after the string it is like int k, and last one is like current string. Okay, it is a string. Okay, now inside here the base conditions are something what we have to write. So whatever the value that I have copied the code previously from the previous BFS, I just put it right over here. Let me explain you what the things are happening. So if whatever the current length, initially it is empty, so we will not enter into this particular one. Whatever the current length, basically if it is greater than this answer is also empty at initial stage. So if it is not, so we are not entering into this and we are not updating the answer. But if current length, whatever the current length that we get in the future, if it is greater than the answer's length, we will simply update it. Or else in the else condition, what it is, so it if the current length is actually equals to this answers dot length, and this current dot compared to answer, if it is actually greater than 0, that means like whatever the current string that we have, it is actually lexicographically largest one with this condition, so that time also we will update the answer. This was the basic condition that we will update, and that is going to the base condition. At any point in time this current length is basically equals to 7, we will simply continue. Okay, this is actually if you haven't solved see the morning solution, let me tell you like in the constraint it is given that this n value is basically less than this k into 8. Okay, so this means that whatever the maximum length that we get, n divided by k, okay, n divided by k, 7 is the answer that we get. Okay, uh, for any possibilities. Okay, because n is basically less than this k into 8 at any point in time. The length, let us suppose n length is actually 15, so k is basically 2 is something what we are given to 2 into 16, 2 into 8 is basically 16, so below 16 the n's length is actually available, so we have to make sure that this way we will basically get to know that whatever the answer that we get, okay, it is basically less than or equals to 7. Okay, this explanation I have already given in the morning, so we will simply continue because we don't want to further try to explore like at any point in time, let us suppose for any particular string we got the answer having length 7. After the 7 we cannot add any extra characters, such that if we try to add that and we try to check if it is basically a subsequence or not, we will not never going to get the answer. Okay, so that's why we are just simply continuing it to avoid extra again trying to check if it is a subsequence or not. So we are just making sure that we will simply continue right at that place. Okay, from here what I'll do is like let us try to go through this all the characters that are there in this list. So ch and get the characters. Okay, whatever the character that we get, let us form the string. So string next is basically going to be equals to whatever the current string that we have plus this ch. So current string is basically initially it is empty, so this ch, whatever the characters that are available in the list, all those characters are also possible answers. Okay, so let us suppose a B and C, all those are actually available in the list which is having length. I mean, whatever the value that we got, the frequencies, they are basically greater than or equals to the K value, right? So those could be answers as well. So this is like first thing that we check, whatever the strings that we get. So it is like whatever the tree like structures I have seen, right? So first we check for A. For all these, whatever the possibilities that we get, we will keep on calling the DFS and try to explore all of them. After completion of all the possibilities for A, we will shift for B. After completion of B, we will shift for C. Okay, that way we will keep on doing this for loop. That is for this for loop. So we simply check that we in the morning I have written this code is Lex sequence. Okay, here what we are doing, whatever the current string that we have, we are checking that whether in this given string it has appeared K times or not. Okay, the idea is pretty much simple. We will just go through this entire string and we will start from the zeroth index. So I is basically pointing for the zeroth index of this length, and the length is basically for this next, it is basically n. So we check that whether this ch is actually equals to next dot character I, whatever the character I is being given to us. So for the zeroth character, whether whatever the character we are exploring from this string, if it is equal, so I basically keeps on getting incremented at any point in time when the I is basically reached to end of the string. So we will simply start from the zero, and the count is basically with something what we increment, because one particular string, something that we got the subsequence, it has been appeared into the string, and the moment this count is equals to K, we will simply return true, because yes, how many times the particular subsequence we actually looking for, that many times we got it. This count was basically showing the same thing. So yes, we simply return true, or else at any point in time if we do not get that counter, so we will return false. Okay, that was the same logic. I'll simply reuse it. So if is lex sequence, and this one, what was the first character was, so first argument was string, next yes and K. So what we will do, we'll pass right over here next. Yes is something what we will pass, and K is also there. So if it is actually a subsequence, then we will simply call with that particular, we will simply go and call that. And in the tree, whatever the recursion tree, there also I have shown that at any point in time, if the answer is satisfiable, we will keep on exploring again the same possibility. So we will come right over here, whatever the new string that we got, we will again go through this for loop, add the character into that one, and again call the check whether it is lexicographical, and again call the DFS. Okay, that is the process how it works. So here again pass the list string K, and the current is basically going to be the next one. Okay, so DFS basically gets calls, and again it checks recursively, keep on checking until and unless it returns back. Okay, so that's all, I guess. We don't have to worry about anything else, and after completion of all this code, we will get the answer. Okay, the answer keep on getting updated, and answer is something what we will return at the end. Okay, so this is how we write the code, and let's try to see if it is working fine or not, if you have any issues. Okay, here it got an error. So what it is saying? Okay, it shouldn't be continue, right? So I just copied that morning's code. We should return back. Okay, at any point in time, we have any issues, we will simply return back whatever the length that is there. If it is equals to 7, we will return back from this function. Okay, let's try to run again and see. It was in the morning, it was for loop, so we have to consider it like continue. But here it is working fine. Let us try to submit and see how it is working. It is basically getting, I mean, morning solution was better than this one. I mean, that is fine. This will also acceptable solution. Now let us discuss about the complexity. Let me connect it, and properly we will discuss about the complexity as well. Yeah, I hope the screen is visible to all of us. Now let's just see right over here on the screen, right? So let us suppose this is the string that is been given to us as a color, and in this particular string we have the worst case scenario. Okay, I have just considered the characters which, whatever the from this particular one, maximum length that we can get is 7. Answer, it is like a b c d e f g. If you consider a b c d e f g is the, again the string is basically getting repeated, so that is going to the maximum answer that we can get it, as in K value is basically 2. Okay, so based on the constraint we cannot have the length more than 16 or more than 15. Okay, sorry, even 16 is not a possible consideration. So yes, n value is basically less than 16 based on this K value. Okay, so now the 7 answer is something what we possibly maximum answer that we can get it out of this one. So each character, if we consider their frequency, each character has basically appeared 2 times. For A, if at first level, if we start considering how many different strings that we can generate, those are like A B, A C, A D, A E, A F, and A G. Okay, so these are the different string possibilities that we will generate. And for each of these possible string that we are having, there are few strings that are not even acceptable. Okay, so the first string that we will check a if it has been acceptable. So a basically appeared two times, so again a is not available in the string, so this is not acceptable. But ba, if ab, if we look, if we ab, if we look, ab is appeared right over here, here also appeared, so it is acceptable. AC is also acceptable, ADA and AG, all these values are acceptable at B. Okay, this is like for the second level. For A, all possibilities we have explored. For B, if we try to see, those are like A, B, A. B is not valid one because B is right over here, A is right over here, and future in this particular further substring, the answer is not available. So yes, it is not a valid one. But so since B is not valid one, we simply cross it out. BB, is it possible to have this BB? It is not, right? So even the BB is not a valid answer. Okay, so simply this is also got removed. Okay, and now from here it is these strings, whatever the strings that are there, these strings are basically available, so all these rest are possible answers. Okay, at this second level, how many strings that we got omitted? Okay, from A it is like 1, from B it is like 2. Okay, this is the worst case scenario example that we are having, and we are just simply checking for last G. Okay, the last character G is actually we have. So for G, those are like GA, GB, okay, and then GC, then GD, correct, and then GE, GF, and then it is like GG. For this G, which is the possible answer? None of them, right? So for G, every single whatever the strings that we have generated, these are not the valid subsequence. Okay, so what we have got an idea from this. For A, at least six are possible valid answers. For B, at least five are there. For C, four are there. For D, there is like again three. For E, it is like two. F, for F, it is like one, which is like GF and GF. And for G, none of them are valid answers. Okay, so this way we got to know that at least okay, we are actually reducing few of the character. I mean, whatever the possibilities that we are generating, those are getting reduced. At first level, how many possibilities that we got? Those are like A, B, C, D, E, and F, G. Okay, all these are seven possibilities that we got. At second level, how many possibilities got? Each of them will be having seven possibilities. Okay, each of them will have seven possibilities. Okay, so it is like seven uh, possibilities for A, seven possibilities for B, seven possibilities for C, seven, 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 seven. It is in total like previously whatever the possibilities that we have, and this particular one, it is again it is in total seven square possibilities that we are getting it at this particular level. Okay, correct, because each character is having again seven possibilities. Okay, so in total seven possibilities that we are getting generated from this particular one for each of the characters, but out of them most of them are getting wiped out. Okay, at this level. Okay, so this way we are at least getting that okay, by going downside we are actually shrinking most of the characters due to the constraint that is actually given to us. Okay, so that is something what clear to us. So what we will try to do now, let us try to take simple smallest example. Okay, with that we quickly try to identify now the complexity, because we are keep on while going downside again for the seven, there could be like half of the possibilities that will be remain for ABC. Okay, so that is something what we will get. So what I'll do is I'll remove every single character. I'll just keep three characters now with us. Okay, this is the string that we have, and these are all the left values also I'll remove. So now we will try to decide the complexity with the smallest one. Okay, because seven length, for the seventh length, okay, let us suppose m was 7, whatever the 7 was possible answer with that one. Now here the string length is basically 3 into 3 is like basically 6 character only we have, so length is basically 3. Previously length was 7 because we have in total 14 characters and we divided it with 2. There were 7, it was having 7 length. Max to max 7 is what we get, and the m value at max it can go up to 7. Okay, beyond that it is not possible to go this m value beyond the 7. Okay, so m is basically 7 for max value, and whatever the string that is, then if we try to divide this k value, this could be a possible answer. Okay, this answer is the maximum answer that we can get it from this particular string. Okay, so we will try to see again for A, the possibilities at zeroth level are A, B, C, these three different possibilities that are there. So at zeroth level, how many possibilities are there? Three possibilities. Okay, at this particular first level it is like A, B, AC. Here it is B, A, B, C, and sorry, it is B, B and B, C, and for C it is C, A, C, B, C, C. Okay, these different possibilities in total, how many possibilities that we explored here? It is like 3 into 3 is 9. In total 9 possibilities that we have explored. Okay, So for 7 it was like 49 possibilities that we got explored. Okay, because 7 into 7 is basically 49, so it is 7 square. This is like 3 square. Out of this, how many possibilities that are surviving? Because this is the worst case scenario, okay, for length 3. So how many possibilities that are getting wiped out? So first is like this one. This is this to survive. This will get wiped out, and all this will get wiped out. Okay. So how many left? Only 3 possibilities that are left for future generation. Okay. For again for this AP, how many possibilities that will be get generated? So it is like A, and here it is like C. For this AC, let me write this AC right over here. Let us take this for AC. It is like ACA, then it is ACB, ACC. Okay, these possibilities, and BC is only the remaining one. For this one, what are the values? Let us just take it down a bit. So for PC, it is uploading a bit late. For here, it is like BCA, BCB, and BC. Okay, these 3 different possibilities that we get. Okay, so at this level, how many possibilities again we got generated? It is like 9. 3 square only 9. And going downside, how many still left? So we will keep on checking, right, whether this is valid or not. So A is not valid. All these values are not valid. Okay, basically if you try to see, none of them are valid, only ABC is the left out. Okay, for this ABC we will further having 3 more different possibilities, and all of those possibilities are not possible answers. So at 4th level, here 3 different possibilities we get, ABCA, and just blah blah blah, 3 different possibilities we get here. How many total I mean possibilities we figure out? 3 possibilities is something what we have figured out. Okay, so if we notice right over here, even if the bigger picture also, if we have at 0th level, whatever the length of the string that is there, that is the maximum possibility that we can get. At 2nd level, it is like 3 square. At 3rd level, again, since maximum depth of this tree is basically it is basically 4 for this particular one. Okay, so whatever the maximum depth that we have, okay, if we divide it with 2, that is the maximum possibilities that we are getting it. After that, again we are keep on decreasing with the values. So initially it goes with 3, 9. Okay, 3 and 9 is the values that we got. Then again 9, 3. This way we are keep on going decreasing in downside, correct? So maximum complexity that we can get is from this one is like it is going to be all these different possibilities. When we consider, it is like, let us suppose whatever the m value that is going to be m, if in this particular case it was 3, basically it is like n divided by k is the value that we have, n divided by k, whatever the m value has been, n divided by k is basically appearing at most whatever the depth is there, that many times the complexity is going to happen. Okay, so at let us suppose it's depth basically got 4. Okay, at max the depth, whatever the depth that we are getting, it is going to reach till 7th one. Okay, because the 7 possibilities hardly we can get it. So in the worst case, it could be n divided by k to the power of whatever the 7 that we have, 7 divided by 2, it is in the range approximately 4. Okay, so n divided by k means like m to the power of 4. Okay, that is the maximum complexity that we can get it, m to the power of 4. N divided by k to the power of 4 is the complexity that we will be having, and these many values are only, we will store it into the breadth first in the queues. Maximum values, these many values are something what we will store it, or else in the stack also, if we apply the DFS, in that case also we will be having stack calls m to the power of 4. Okay, this is the